Hey everybody, this is Larry. This is me trying to do a problem that I haven't done before. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this one. What I want to do, there's so many. Let's do a hard one. That's what I was trying to do. I was like, let's just do a hard one. Today I feel like my body's a little bit weak, so maybe my brain will be a little bit stronger. I don't know if that's true, but let's give it a try anyway. Alright, today we have 2969 nice minimum number of coins for fruit 2. You had a fruit market of different types of exotic fruits on display. You're given one index the way price, write one index. Where price is above denotes the number of coins needed to purchase the ice fruit. Why is it 8 hints? But also, the thing that I'm just shaking my head about is that why is this one index? It doesn't used to... Like, it doesn't at all matters, right? So yeah, I don't know. Anyway, it's not a big deal, but sometimes people make very questionable things that deviates and kind of mix it, and it's in bold, right? But it doesn't seem to matter. But okay. The fruit market has the following offer. If you purchase the I fruit at prices of I coins, you can get the fruit next I fruit for free. Note that even if you could take the fruit J for free, you can still purchase it for prices of J to receive a new order. I feel like I solved this problem before. Maybe that was the part 1, and maybe the constraint's a little bit lower. This is 10 to the 5th. That means that obviously you cannot do n square. Maybe the other one is n squareable. I don't know. Let me actually... Honestly, let me just look real quick, because I really think that I have done it before, and I don't know if I'm just like, delusional or something. Okay, so maybe it's this one, right? Okay, yeah, I guess so. Oh, I plus 1, 3, and I guess this was during a contest. Was this last year? I guess so. Okay. And here the n is 1,000, so I probably did n square thing. Yeah, okay, so this is n square, right? Okay. Just want to get that in there, I suppose. So okay, so the difference between so at least I know that I'm not dreaming of problems. I have seen this problem before, but the constraints are a little bit different. It's 1,000, so that one I did 1,000 square. Here's 10 to the 5th. Okay. So okay, so you have the two things that you can... So the tricky thing is that and maybe this is on a thing. Yeah, I guess this is actually an example 1, right? Is that even though this buying the first fruit allow you to skip... Wait, what? Oh, the I fruit. You get the I fruit for free, not prices of buy. Okay, so you buy the first one because you have to, because you always have to buy the first one, maybe. You get to skip the next one, but if you buy this one, you also get to skip this one, which is cheaper. So the thing is that you are able to skip, so that, but you might not want, or you may not want to skip all of them because it's just cheaper, right? So that's basically the idea. Is that so in a naive way, you might have done, and this is a hard problem. This is a hard daily thing. So I'm going to skip the dynamic programming because I don't know the answer yet. So I don't know how to I'm usually recording these live. Not usually. Every time I'm recording these live. And when I do the explanation, I actually do even the explanation live, right? It's not pre-prepared. There's nothing prepared about it. It's just that maybe not most, but a lot of the times I already know the answer by the time I are coding it. So I'm able to explain it in a way that is more, just more teachable. I don't know. I try to anyway. But right now, to be honest, I don't know the answer. I'm not gonna lie. So the idea here is that, the naive idea is that, you know, you have this function, and I'm not going to go for this reason, at least for now. Maybe in the end, I'm not going to go over the nuances of dynamic programming. And I would also say that if you really do want to, you know, if you really do want to understand some of the logic behind this problem, maybe do a search on 2944. I most likely have a video on this. If not, let me know in the comments. I have a video on this problem, and it probably takes you through some of the logic. But the way that I'm thinking about it is that, you know, so maybe a tick, no tick idea would be something like, you know, you tick, you go index plus index or whatever, right? And then no tag, you just go index plus 1, and then, you know, there's some cost function or whatever, but that's the idea. However, you cannot skip over all of them, right? So that's basically the tricky of the nuances. And if you kind of look at the other way, the other problem, the way that I handle this is just by giving it n squared, so that here I added a dimension called free, because buying index gives you index plus 1 free. So then if free is greater than 0, we also just, you know, subtract 1, so that we can use up a free skip, if you will. So this is buy and this is skip, right? By adding a dimension. But of course, this is going to be n squared because index is all of n and free is all of n. So that's probably in that video. So yeah, so now we're trying to do something a little bit better than that, or a lot better than that. And I don't quite know yet, to be honest. Can we make a query into the thing? There's so many decisions. This, I'm not gonna lie. This definitely has a potential to be one of those problems that will take a while. So definitely, I don't know, maybe watch it on a little faster speed. So the thing is that, you know, so given that n is 10 to the 5th, the only way we can the only way that we can keep it the only way that we can keep it fast enough is something like either linear or n log n, right? And I just have I'm just playing with some ideas in my head, not really articulating it. That's my fault, but I'll just kind of do a sanity check before I say some stuff. But the first thing to notice is that if index is like n over 2 or something like this, roughly speaking, the second half will all be the second half will all just be the price of the thing, right? Now, can we take advantage of that? Because then now, instead of the base case being at the very end, you have half of the things being the base case, right? And what I mean by that is something like, okay, maybe that's actually a bad example. Let's just triple this up a few times. Right, so you have something like this, right? Maybe just a long enough array. It doesn't really matter what the values are. So then half of them are like what? Like, let's say this is half of them. Maybe that's roughly right. But that means that if you buy anything from the second half, you're already done, right? So that means that this is the base case. Does it change the answer? No. I mean, yeah, obviously it doesn't. Otherwise, if you change the answer, you can only get a wrong answer, right? But I'm trying to think of a way to kind of construct this almost like not necessarily backwards, but here goes to say here or something like this. So then that means that No, but if you go from here, so okay, so this one means that we want to take the min of these cells, including this one, right? So that means that this one wants to take the min of these as the base case, because that's the answer. And then to get to the end, oops, right? And then this one means that it's how far does it go? 5. So then here now this one is the min of these things, right? If you take, but if you don't take, it's just the next cell, which is what you have to take with you at that cell. Right, so here now we're just focusing on always taking because there's no take, I think. And you can, because here you cannot do no take because you assume that everything is already not free. So I think now I see a pattern. Okay, I mean I think that's good. I'm going to draw it out real quick, just because I don't think I explained it that well. I think I just kind of I think all the visualization is for me and not for you at home, which is true. But okay, so let's say you have an array, right, of all these elements, and let's just say this is half the array, and then now you have this cell, right, and this cell allows you to jump to here, right, or something like this. It's roughly I don't know, I can't do math, but it's roughly here, right? But that means that we can also, in a way, you could say that this is jumping to here, but also it is actually you can also think of it as jumping to any of the in-between ones, right? Because by definition of this function, jumping to the in-between one is the same, because jumping here and forcing the jump from here, it's going to be the same because it just goes to the end. Because both of these places, or all of these places are one step from the end, right? So that means that the cost here is going to be Gucci. Okay. So then now, okay, right? So that means that here, we can also get, let's change the color real quick. And the same idea, right? Which is that now here, I don't know, it's just the same as this length, right? So that means that here we can jump to, let's say the furthest that we can go is, here, and it's just like 2 spaces from here for that. Or maybe I'm wrong on this one, but either way, right? But then that is also equivalent to jumping the min to jumping to all these. So then now we're trying to get the min of all these other cells. But then now you notice, and also I just want to do one more layer to be clear. And then now here, and of course this span is a little bit smaller, but that's fine. So then this goes to here. So that means that the brew will just only care about this subsegment, if you will, right? But basically now what we're saying is that we're trying to get a min of a segment after we calculate it. And of course this is a way yeah. Okay. Yeah, this is a doable job, is my point. So another way we cannot do this recursively. No, yeah, we cannot do this recursively. And there are a couple of ways to do this. I think if you're really annoying, or I hate to bring this up, but it is just for completionists. To be annoying, you would you could definitely use segment tree on that part of it. You update and then you do a segment tree, log n, get min, and you're good, right? Okay, fine. Maybe I'll do that later just to show that I can, but there's actually another way of doing it which I prefer because it will keep it O of n. Actually, maybe I'll do the seg tree first, but either way. But the way that I would explain it is that on a recursive way of doing it, instead of tick, I think the observation, now that I think about it a little bit more, is that, as we said, we already took away the no tick, so then it's tick from index to index. But instead of going all the way through index, and maybe it's index plus 1, I don't know, just off by 1 or something. I guess that's the only reason why it is 1 index, is because you can skip the I through at the next I. The other problem actually just say I plus 1 with 0 index, so I don't know. But in any case, but yeah, but here you can say that if we take this one and we skip only 3 instead of all of them, that is the equivalent of just skipping 3 instead of skipping all of them. So another way to think about this is that now you can write for loop for, I don't know, x in range of index plus 1. Maybe it's off by 1, but you get the idea. I don't know. It is not going to be real code anyway. So now you have index plus x plus the whatever thing, which is price sub index or something, right? So then now, you know, your best min, best, right? Return best, something like this, right? And this will give you, roughly speaking, the right answer, right? And you could probably test on the other one. Maybe we'll do it for fun. But yeah, maybe it's off by 1, but you know, right? Okay. But then here, the regularization is that you're minning over all these things, and they're actually, yeah, and you're minning over these things, so then now you just have to structure in a good way. And the way that we talked about it already should give us a good structure, which is that we can do dynamic programming, right? Let's just say we start with minimum, so let's just say infinity, right? Times, do I want n or n plus 1? No, I mean n is fine, right? And then now we start with 4. Yeah. N minus 1, we want to go down, and then at the end we return dp of 0, right? But the idea here is that let's just say this is a base case. If I plus 1, which is the number of food that you can take for free, that is greater than or equal to n. I may be off by 1 in some of these things, I have to double check. But yeah, we just set it to the prices sub I, because that means that after you bought this, you can skip all the way to the end, right? Continue. Otherwise, we want to get a range, which is that we want to get the min. We want to get the min from I plus 1 to I plus 1, right? I think. Like, we may be a little bit wrong on this one. But the idea here then, and I'm going to do it 2 ways. One is the way not creative, I am not a fan kind of way, which is using segment tree, right? So then now here, I do have, actually, I'm not gonna lie, I do have here, sorry, hang on, give Python min segment tree code. So I just asked GPT for the template because I'm mostly lazy. Yeah. Okay. I mean, I have it written, but I don't know. It's just. Okay, so this is the thing, right? We don't. Okay, I just call it infinity, right? And that should be good. Yeah, I guess we can just do it this way, actually. So then now we have a seg tree is equal to seg tree of dp, right? And this is just, so the thing that we want is a couple of things. One is update, just update the value of a thing, and then range query, which gets the minimum value in the range left to right, which they claim to be close. This code is actually a little bit nasty. I don't like implicit checks, but well, nonetheless, this is what they have, right? There's so many seg trees variations. I think ChatGPT gives me a different one every time. But yeah, but then here we just have to go back a second, and when we update, we also update the tree, right? So update I to prices of I, right? Yeah, that should be good. And then now, also just as a disclaimer, if I get an error from this, I don't take all blame. But yeah, so this is that, and then maybe max of, well, not max, min of this and n, right? So that it doesn't go over is my point. So then now this is the best first say, and then dp sub I is going to be best plus dp sub I because we take a step to go to the best, and then now we also update I as the best, and that's pretty much the idea. Maybe it's off by one, maybe it's off by a lot, but that's basically going to be the idea, right? And I'm not going over segment tree in this particular problem, just to be clear. Am I returning infinity? Maybe. I said maybe. Oh, this isn't right. This is priceless of I. That's why I was giving infinity. All right. Well, maybe not. Is best always? As I said, I don't. This is what happens when you use someone else's code. You have to, It's because of this thing. I don't know why this is returning infinity. I don't know how this range query works, but okay, fine. Min of I. What? But this is returning infinity, but why? Tell me why. Yeah, this is what happens when you use someone else's code. So 0, 1. So the current I is 0. So now it's going to ask for 1 and 1. That sounds right? Right? Yeah, that sounds right, because this can only jump to here. It's a little bit off though, but I mean it still should not be infinity. What is dp sub? Dp sub 1 is 1, so have we not updated correctly? Oh, this is wrong, but still, I don't know why this is giving infinity for is this one index? There's a lot of like random stuff like this that I'm always just confused about. Like, yeah, I think this is one index, that's why. Alright, fine, right? I don't know, this should be n plus 1, I don't know. Two times n. This is what happens when you take code. I usually don't write the seg tree this way. I don't know. It's very confusing. But yeah, in theory, this code is at least an idea should be close to right. But yeah, I don't know. And now we're pending. ChatGPT has been. Alright, now Leetcode is having issues. Of course, why not? If I can just update, refresh. Okay. Like I don't want to debug the tree code, right? So that's why I'm like, okay. I don't know why Leetcode is just having so much issues all of a sudden. I can't even like run code. What I was going to say is that now you can see that why people use segment tree is because this is a Yeezy plugin. You can see that this is mostly right and this is good. But of course, apparently I do not have a Yeezy plugin. But I mean, the code here looks roughly right. Maybe this part I'm not super sure about. But I don't get how they store the data, and I don't know why Leetcode is just having issues. I mean, I don't think it's me. My internet seems okay, though now it seems like maybe not. Maybe I'm lying. No, my other stuff looks okay, so it's just Leetcode. Of course, Leetcode has issues. Okay, well, alright, at least I didn't just dream it up. But I don't know why this segment tree is. Oh, and I will never know because Leetcode is having issues, as common. But why is this 1 and 1? 1 and 1. Why is that? Wow. 1 and 1. Oh, right is exclusive. I should have actually gotten that. Okay, fine. Maybe that's why. Because it was just now that I know. I mean, I did know it, but I didn't. And of course, I cannot test this anyway because, as you can see, Leetcode is crapping out. The story of it, and I'm sure if this was the contest, it would be ranked 2 for some reason. You know, because it affected everybody the same somehow. I'm just checking to see whether it's my internet, and still it is not. It is just Leetcode having issues. Let me see. Maybe I could go for firewall. Might as well. But I think it's just Leetcode server having issues. I don't usually cut away, but I might cut away if you know. That'd be funny if it's because of like my router or something. Maybe it is. Not my router, but I'm using a VPN through like Germany for some reason, and now it works. But okay, so I don't know if this is right, but it seems like I was just dumb. Okay, no, it's still not right. But that's fine. I mean, now at least we have a real thing. Now we can debug. But I am curious. So yeah, and maybe this part is a little bit off by 1 as well. So I don't know. But I usually like mine inclusive, but that's why I'm kind of but it is what it is. Okay, so this is the DP. I is 0. The short. This is going to give you 11. So why is this? Is this not 12? It is 12 then. Oh. I always read this wrong. It's behind. Okay. Why? Because it's 0 goes from 0 to 1, and here 1, the min is take the second fruit for free. That means that you have to get to the third fruit. Okay, so that means that I actually miss, because okay, so you get that one for free, so you get the next one. So we actually have to do just like one more, which is fine, right? It is very confusing though, or easy to mess up, for sure. I'm gonna give it a submit, but I'm just a little bit lazy. So okay, let's actually take a look real quick. Let's just see about right. 1111. Okay, that looks good. Let's say we have 9 elements, and then I'll be more confident. First 5. Is that true? Maybe that's true. I'm just gonna submit. I mean, the idea, like the idea we knew was gonna be right for a while, or by we I mean me, but it is possible that I have a silly off by 1 or something, because I think that, like that, I'm not surprised if I have it off by 1. But let's take a look at this debugging and see why. Tell me why. Why does it always print an infinity? It already updated. 46, 37. Oh no, this is the actual thing. Okay. Okay, yeah. Just want to make sure. So 0 goes to 1 and 2, because it could skip 1, or which gets to 2, or then skip none. Okay. Skips you first. So 0 is 1 plus. So this is good so far. It should be 37. Why? I mean, I'm worried that this isn't off by 1. I think that's the thing that I was kind of in the back of my mind, to be honest. Yeah, and I guess just adding that fixes it, because I knew that I fixed this by fixing it here. So it just means, I mean, it's the same bug is what I mean, which is that it was, but I don't know. I wasn't confident about it. That's why. It just means that it's the same thing of from 0 it goes from 1 and 2, because it skipped one of them. So then from like the middle, it skips enough of them, and for that reason. So let's give it a submit. Hopefully, yeah, that was the last off by 1. Maybe it times out. Maybe that's fine too. But yeah, as you can see, in theory, if I wasn't terrible at off by 1s, you can see why this is so easy to write, right? You just kind of I mean, it's still a very hard problem. I'm just saying, like, the implementation after idea, and if Leetcode wasn't having issues, or maybe my router's having, or my routing, not my router, but my routing is having issues with Leetcode. But in either case, yeah. But the other thing that you can think about is that this is the window in which we're doing this range query, right? So this part we don't change, right? But the part that you can optimize this out is that you can use a queue to get a queue to kind of get this thing on, right? And they're probably, if you're very smart, and I am not, which is why I'm saying it that way, you can definitely you can definitely keep track of a lot of stuff, like keeping track of the indexes of the queue, so that you are very, very precise. But the idea here is that now we have a mono queue, right? In a queue, and here we want to store two things. We want to store index I. We want to store prices of I, and then now we want to store the min. And this is mono queue for mono min queue or whatever. I forget about queue, or Excuse me. And if you want to learn more about MonoQ, I do have a video teaching about how to think about these type of problems in general. So definitely check out that one. But yeah, the idea here is that okay. The idea, and I don't actually remember it. That's why it takes me some time to go over it. Or I mean, I mean that in the sense that once you get the idea, you don't have to memorize the code, right? But I guess if you memorize the code, it's a little bit faster and impressive. But anyway, so here the idea here is that we want to eliminate answers that are no longer possible, right? And here, if this number is smaller than other numbers you're appending to, then those numbers are no longer possible, right? So then now, in a way, it will create a monotonically decreasing queue as a result, because you're always pushing at the end, and it always remove answers that are not possible. So then here maybe you do something like, while length of queue is greater than, and we want to add from the right. Yeah, okay. And queue sub. No, we want to check the end of the queue, as we said, and the price. If this price is, remember that every value. Oh no, the way, so we actually don't need an additional thing, right? Because it is implied that every value, if it is in the front of the queue, it is the min. Because if we add it to the end and we remove stuff from the end, that means that you're monotonically, oh no, it's not monotonically decreasing, is it? It's monotonically increasing because you're removing stuff that is lower. So when you add stuff, it's going to be at the end, right? So here, if this cell, the last item is greater than price of sub I, or maybe equal to, say. No, let's just say it's greater, because I think there's some stuff about indexing. Okay, yeah. Maybe, I don't know. Then we do pop from the right, and then we append from the right as well, right? And then now here, so now the invariant after this, actually I guess this is still, we still need to do this here, but the invariant, so this you get for free, right? And this you get the min. And then now the query is that Q contains all the min values. So the thing we have to do is that we have to narrow the indexes from I plus 1 to this thing. So, and here, keeping in mind that I recount from backwards from larger to smaller, that means that we have to keep making sure that this condition is met, right? So while length of Q is greater than 0, and Q of now the front, the index is greater than this one. I may get off by one again, to be honest, but I think if it is equal to, then you do Q dot pop left, right? And then now I think this should always be true, but it is a little bit awkward. But yeah, so now it means value up to I plus 1 plus 1, right? And this one, we call that we had a plus 1 extra. So I plus 1, I is the current index, I plus 1 is the number of free fruits that we can take, and 1 is the next fruit after taking a free fruit. So then now we can remove best, and the front of the queue, the prices of that one is going to be min. So then we do that, and then we also do this thing again where, yeah, I guess maybe we can just do, I think, okay, we can probably take this out. Put it here. Yeah, we can actually write this as maybe else. Let's just say best is equal to 0. Then we can take this out. Best is equal to Q01, and then now we can do this thing, right? Hopefully this is roughly right. Why is length of Q is less than 0? That means that there's no object here. Oh, which for... Yeah, okay. I guess this is technically true for that, but... oh, whoops, I don't need this anymore. So I don't... So this is actually only for here. Very sloppy, actually. Okay, we have the wrong answer, but, you know... it is what it is. Oh, because this is price sub I, because I copy and paste. It should be dp sub I. Yeah, okay. Now let's give it submit. Oh no, so close. I mean, it got these things right, so I guess we were mostly right, but I'm probably a little bit sloppy on some stuff of the indexing. Is it maybe this one? I wasn't sure about that one. Nope, that didn't fix it. Prices sub I. Okay, so it's not one of these. Okay, let's actually look at the thing then. Let's print dp. Okay, so the last 4 should be just that, and then I'll put 75 when it should be 63. Okay, so it's 14 plus one of these two, so that's going to be already wrong. 14 plus 49, right? Yeah, 14 plus 49 should be right. So that means that my Q is wrong. Is this too aggressive? Oh, no. Oh, this is DP. Not, silly mistake. Okay, yeah. I fixed it here, right? I fixed it here, but then I just forgot to, yeah. Because we want to get the minute, because I wrote it for the this case, but I need it for the general case, and I kind of refactored it without thinking about it. All right, let's give it a quick spin. There you go. Silly mistakes aside, that's pretty much the idea, right? And I didn't actually go over the segment tree solution too much because I was really annoyed about the indexing, really. I think everything it was fine. I'm just really bad at indexing. I got the problem. Like, I can solve problems, but I suck at indexing. Maybe I need to practice that, to be honest, because it's been something that I've been just really off by one a lot in general. Yeah, I really should be better about thinking about this. This is costing me a lot of issues, even in the last contest. But yeah, in the segment tree solution, and both solutions are kind of the same, and you can kind of rewrite this as the same way, right? Let me actually rewrite this solution as well, right? So we can just say else dp best is equal to this thing, right? Yeah, and here best is equal to 0, right? And then now you have this thing, right? So even a shorter code, right? A little bit tighter. So in the segment tree solution, anyway, in a segment tree solution, you can see that the construction of the tree is going to be n log n. This is O of n. This is an n loop. O of n from the segment tree two O of n loops. So this is n log n. The second one with the q, with the mono q, it is yeah. I mean, this is O of n space, and everything is just, this is O of 1, O of n total, but keeping in mind that we can only pop n times, and this as well, because there are only n items in total to be added and to be packed, right? Because we only append n times. So this is O of n, so this is linear time, linear space, and that's all I have for this one. Yeah. Kind of took a long time for this one, mostly because I suck at indexing, apparently. Oh, this is just a typo. I'm just being very sloppy. But yeah. And you can see that, well, I don't know. I feel like coming up with the DP part was easy, and then I just suck at indexing. But that's all I have for this one. Let me know what you think. Thanks for watching. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.